My family makes a lot of laundry, and I hate folding it. Don't you? I've wanted to make a laundry folding robot for a really long time, but it's a really hard problem to solve. First you've got to turn the clothes right side out, then you've got to put them in some known orientation before you fold them, and finally figure out who owns each piece of clothing so you can sort it into a pile for that person. But my family hang dries laundry, and one day while I was hang drying our laundry, I realized that I had already solved the first two problems. The clothes are turned right side out and they're in a known orientation when you hang them on the line. That gave me the idea for a proof of concept laundry folding robot, and that's what you see right here. It manipulates the laundry line and then moves its arms around to fold each piece of clothing, and then it uses a custom image classification model to determine who owns each piece of clothing and sort it into the correct pile for that person. Now, obviously, it's a proof of concept. There's lots of exposed wires. This thing's really rough and yucky looking, but it folds clothes and it sorts them. So it proves the concept really well.
Here's how it works. The Raspberry Pi turns on a motor, which moves the laundry line forward, advancing the piece of clothing. The Raspberry Pi camera takes photos as the clothing advances, which are compared to the background to determine the position of the clothing item. The average position of the clothes in the X and Y dimension are calculated, and the clothing is advanced until it's centered on the vertical fold line of the robot. A folding arm advances out, and then it moves up to the average Y position that was calculated in the last step. Basically, it moves into position so that it's halfway between the top and the bottom of the garment. Then the metal arm pulls in preparation for the first fold. In order to make the first fold, we have to drop the top of the garment, so servos at the top of the robot pinch down and unclip the clothespins holding the garment to the clothesline, and the garment falls. It's now folded on the horizontal line. Next, the folding arm repositions itself so that the top of the folded garment and that metal bar are up against the wooden folding bar. Servos come down and pinch the garment in place around that metal bar, and then the metal bar is able to retract, leaving the garment in place. Once it's fully retracted, the wooden folding bar is folded in half by another servo, and this is the second fold of the garment. Now, another movement of the metal folding arm assembly prepares for the third fold. That metal arm is dropped down and behind the garment, and then that arm is extended, and the whole assembly presses away from the wooden folding arm, so that when the garment is released, it is folded a third time. The metal arm moves back against the wooden arm, and the garment is repinched by those same servos, completing our third fold. Last, we reuse the image that we took at the very beginning of this process, and we apply a custom image classification model. So a little bit of AI here to determine who owns a piece of clothing. Now there's only two categories in this, either it belongs to me or to my daughter, and then at this point we can use the metal placement ramp to sort those into a pile, either for my daughter or for me. So for me, I will actually push the ramp out and it slides down the ramp and into my pile. For my daughter, it drops directly down into her pile. In the future, I'd like to have a lot more piles and a much smoother sorting mechanism so that you can sort into more than just two piles, but this is a good proof of concept.
So there you have it. It's pretty cool. After the break, I'll show you how this thing was built. I'll show you how to create a custom image classification model to sort the clothes based on who owns it. And then I'll give some thoughts about improvements in the next version of this so that it could be something that actually can stand alone and operate in your backyard, folding clothes as they come off of the hang dry line.
So let's get started building. You can go out here to this GitHub. It's linked in the description below. This has all the information that you need to make this thing a reality. The first file here has the schematics, so how you're actually going to wire this thing up from the Raspberry Pi to all of those motors. Just below that are the actual parts lists, so get a hold of all of these parts. These are motors, Raspberry Pi, as well as the various things that you need for the frame itself. And so once you have those things in hand, you can head down to the 3D printed files. These are 3D models of the various things that get used in here. So head to maybe your library has one of these, or a makerspace, or if you have a 3D printer, just use that. You can use PLA, most common filament there is, 40% infill and no brim, and print those up. Once you've got those 3D printed pieces and your all those various parts, you're ready to assemble this thing. Once you get it assembled, there's instructions down here for how to set up your Raspberry Pi. So you'll actually have to run these on your Raspberry Pi. I used a Pi 5, but you should be able to use a 4 or a 02W, which is quite inexpensive. And then the actual code that will run on this thing is this laundry v1.0.py. So you'll just run this file right here, and it'll give you a few prompts in the command line so that you can advance the program and see it running. There's four main components. The base here, the linear actuator setup that are, it's 3 linear actuators in an orthogonal configuration. And then the top, which actually moves our clothesline. And last, the electronics, the computer, servo motors, etc. Going into just a bit more detail, the base here is just a 2-foot sheet of plywood by 4-foot sheet of plywood, and then these are 2x2s. All these pieces are 2x2s. These are 4 feet tall, and right here we have 10-inch, 1-inch, and 10-inch segments of 2x2. Now I screwed on a couple hinges from the hardware store, and then I did have to put a little piece of string on the back here. These hinges don't want to close evenly, so this allows us to fold this thing shut and leave a gap right here. Otherwise, this might be the only hinge that swings. And the reason for that gap is this arm right here is actually going to be situated right in here, so we can't pinch it completely shut because we have a metal arm sitting in there. So that's the base. After that, I just used some 2x2s at 45-degree angles to secure everything in place. The second component is this linear actuator setup right here. It's 3 linear actuators. You don't have to build it this way. All you need is to make sure that they're at right angles to each other and secure. They're not going to wobble. So the first thing I did was I took a piece of re-rod, stuck it through this linear actuator here. This is a 14-inch linear actuator. And on the top of it, I put a 20-inch linear actuator. I just zip tied it down for now. Not pretty, I know, but it's a proof of concept. And this 20-inch linear actuator, this arm right here, can move 20 inches out. That's the reason that this is 20 inches long. It's actually going to extend along the length of this. In a future revision, I think that a 30-inch linear actuator and a 30-inch arm out here is probably a better choice because you can fold bigger clothes. So after I got that situated, secured on here, I built this wooden structure down here, and then I screwed this linear actuator into it. And the result of all of this is, because of this piece right here, it doesn't want to wobble that direction, and because of these little legs along the sides here, it doesn't want to move in the this other axis right here very much either. The last thing is this 10-inch linear actuator is just meant to push the entire assembly out, and it's actually what gets screwed onto our base over here. The point of this thing is just to be able to move the rest of this assembly out. So I drilled a hole in the wood, sunk a screw into the linear actuator arm, and this whole thing right here is going to sit right about here. And this arm will be flush with the folding arm over there. The third component is this thing. It's actually what moves our line. So this motor right here has a little circle put on it so that it can actually move the clothesline. And then this also houses all of our computer. So it's easier to see how it works in situ over here. It's also 10 inches wide. It fits right on top of our base right here. I'll screw that in place and put some 45s on to hold it. And then out on this end over here, I will mount the camera. And the reason for that is if the camera is sitting right here and it takes a photo, we'll get a full photo of the clothing that's been spun into place. And as for the clothing, this motor right here is just mounted to this 1-inch piece of wood. But on the other side of it, the D-axle is actually connected to that little circle right there. So when the motor spins, the clothesline is going to be wrapped around that circle right there. So when the wheel spins, it'll actually move the clothing line and thus move our clothes into place. So the electronics and camera over here will be able to take a picture of that clothing as it moves into place, figure out what it is, who it belongs to, and then move all of the arms to fold it and drop it off. Now the last components over here are the electronics components. We've got 6 servo motors that are mounted flat in this style of case right here, and we have 4 of them with these hook arms and 2 of them with the straight arms. There's 1 servo motor over here that's mounted vertically, so you can see it's got little screw mounts here, and it's setting up vertical, and it's got a long extender arm on it. And then of course you've got your Raspberry Pi and camera and all that sort of stuff. And then over here we also have some electronic speed controllers and a power supply. And we use those electronic speed controllers to move these big linear actuators and our line mover motor that we saw earlier that's going to be mounted way up high. Now just a couple points on these. I used all number 4 screws on these. They're small enough that they actually fit into these holes. And I mounted all of these so that each pair has this line of screws on the back. So the arm is on this side and on this side. And the reason that that's done is we can actually connect these two arms up with a single bar, and then they will move in tandem. So when they come down, they'll both move down, and that bar will pinch whatever's down below. Now these two are used to actually remove the clothespins and initially drop the piece of clothing that we're working on. These over here have a different style arm. It's this hook, and that's meant to reach over the folding arm. So this circle right here is actually going to sit right inside of this hook right here. And this will pinch the clothes right here, and again, it'll have a bar connecting this arm all the way over to there. So that's the reason that these things need to be back to back. There's actually going to be a bar connecting these either hook arm or straight arm in between them, and they'll all move in concert together, top to bottom. So that's the last point. When you assemble these, I just took one of the arms that comes with these servos, clipped off the end right here so that I only have a straight piece coming off the back there, and I set it up so that the range of motion goes from here, that's bottomed out on the servo, all the way back to here. So you can see that when it spins, it's going to be able to reach all the way down and pinch the clothing, and then retract fully so that it's out of the way for when we want to do clothes folding. This one is just slightly different. Its fully retracted position is here, and then when it swings down, it's actually going to pinch the clothespins, and so its fully activated position is here. So you want to set those up that way with those arms, and then we're going to stick it all together, and we'll take a look at that next. Here all that is stuck together. You see we've got the 3-axis linear actuators here, and then the laundry mover motor with its little harness here. This was secured to the base with just a couple screws from that linear actuator into the base, and it's set up so that this 20-inch linear actuator arm will extend directly across this wooden laundry folding arm. The top here is set up so that the laundry line is about 8 inches from this bar right here. That should allow our linear actuator arm to come out beyond the reach of where the clothes are hanging down, and then pull it back in to over here. So that's how we decided how far to put this apart. I went ahead and put on an extra support arm right here. It's not actually necessary, but since I already had to mount this computer and camera over here, I did it. Look, it's not pretty, I know, but it's also a prototype, so I just put up with it for now. So we've got all of that stuff stuck together, and then we've assembled some various electronics on here. You've got electronic speed controllers over here. They control the linear actuators, as well as this motor up here, and then the power supply sitting down there on the base. And then we've just stuck on all of our servo motors and the Raspberry Pi and camera. None of those are connected electronically yet. We'll do that in the next step. But the way these work are, we've got 2 servos up here and a bar between them. And the way this works is, you can imagine the clothesline going right there, clothes are hanging down from here, and you've got a couple clothespins along here. When these servo motors activate, they close this bar right here, which pinches those clothespins, and that drops the clothing down. And then down here, these are rather tight tolerances. Next version I'll make it a little less tight. We put these 2 servo motors as close to each other as possible in the middle of this bar, and we connected them with just a small piece of wood. And you can see now how it reaches over this arm right here, and this whole thing can come up and down. So when we want to pinch the clothes in place, we can pinch it with these servo motors right here, and then still have, this is still loose. We can retract this arm and send it back into there so that, the clothes are being held by this pinch right here. And the same thing goes over here. The one thing that we had to do on this side was give a little cutout, and that gives relief so that this can fit into there. So when the vertical servo is right here, it's attached to a screw right here. So when this closes, you can see right here that there is a little bit of relief there where these things can all come together. This metal arm will actually be completely retracted, so this will close tightly, and we'll have folded the clothes a second time and pinched them in place with all of these arms in preparation for releasing all of those servos at the same time, and then the clothing can drop down. Onto the electronics. The first things is the power supply and getting the power to all of these electronic components. So we've hooked up the 12 volt, 5 volt, and ground, and they come over here to these wire nuts and then distribute from there. So the first 12 volt and ground hits both of these ESCs, and then the rest of it we've just got to take 5 volt and ground to everything else. So we run up here and we hit these wire nuts, and you can see that I've inside the wire nuts I've actually hooked up these little connectors here so that we can do our quick connects to the servo motors. They both get 5 volt and ground, and then I ran another wire over to this side, wire nutted, and did the same thing. All the servos get their 5 volt and ground off of there. We continue running the 5 volt and ground all the way up over to here, where we have another wire nut, and of course we're powering these servos same way, and then this continues 5 volt and ground all the way over to here, where again we wire nut and we head out to 5 volt and ground on the GPIO pins of our Raspberry Pi. All right, the signal wiring is done. We have the Raspberry Pi sitting here, so all the signal wires plug into there, and we have a total of 2 wires going up to these 2 servos right here, 4 wires for these horizontal servos, 1 for the vertical facing servo here, and then all the way down to here we have 1, 2, 3, 4 pulse width modulated amplitude. So that's like how strongly we want to turn on those motors. So we have 4 channels on those 2 ESCs, 4 total wires going in there, and then we have 1 pin that's coming down here, and it hits this wire nut right here, and then it divides into 2 of these little headers that plug in so that you have control of both of your direction pins. And then same thing, we hit the same wire nut, this red wire heads over to here, and we do the same trick where we control both direction pins. So what happens down here is we're going to change the direction of all 4 of those channels at the same time. They're either all forward or back, but we only turn on the amplitude of one of those channels at a time, so we're never going to have 2 motors running at the same time. Now one more thing, I use little screws here and here. This whole arm is going to slide out, so you need some slack in those wires, and I just wrapped around a couple screws right there so that this can push out, and the slack will be taken up between those 2 screws, but it won't put any torque on this right here. Last thing, every one of these pins is going into a typical header. So what I did is I just soldered it to one of these 18 gauge solid copper wires. I did not need to use Ethernet wire to get better, grounding. The pulse width modulation still works pretty well. All the servos behave correctly. So I soldered to one of these solid copper wires. You can see there's a whole mess of copper wires going up here. And then when they come over to a servo pin for over here, you see the same trick where we solder and we connect to one of these typical headers right here and just plug it into the servo header. And then give it a little piece of tape. So we've got our power, ground, and signal going into every one of those. And I did the same tricks down here. Once I got down here, I converted back to something that I could plug into the headers on those ESCs. This is already in the GitHub, but for reference here, here's a Raspberry Pi pinout, and then how those pins on the Raspberry Pi connect to all of those motors that you just saw in the video. Last addition to this thing right here is a sorting ramp. This is just a piece of roofing coil. It's set just below where the clothing will be folded so that as it falls, it will redirect it into a horizontal position. But it does a bit more than that. When we head around to the back here, you can see that it's actually got a wooden frame and another linear actuator that will push it out. So when we activate that linear actuator, you can see that it's pushing the ramp out in this direction. And what that does is it gives us 2 options. The default will drop directly below in a horizontal position, but if we detect that this piece of clothing belongs to someone else, in this case to Dad, this linear actuator here extends, and we can actually push the clothing out a little further into that position out there, which is going to be the dad pile, whereas this position right here will be the daughter pile. So to build this, it's actually just two pieces of 2x2, each of them 20 inches. We've got 3.5-inch bracket in between them, and then these bolts right here just provide us with a hinge point. This is just screwed onto the other frame that we have, and this is just a 6-inch linear actuator here so that we can push it out and back. In the future, I'd like to have quite a few more sorting options, so my guess is we'll actually have a fixed ramp right here, and instead we'll have a bunch of bins along the bottom. So each person, or each shirt and pants for that person would be a different bin, and we can actually move the entire set of bins back and forth, and then drop the clothing into the correct bin for that person. Now that sorting ramp, and also the demo videos at the very beginning showed that you actually do need to know who owns a piece of clothing so that you can sort it into the correct pile. To do that, you need a custom image classifier, and this set of steps is how you create a custom image classifier. Create a custom image classification model. This is a whole bunch easier than you might expect. All you have to do is type in MediaPipe Model Maker image classifier demo into Google, and you'll get this. This is a Google Colab, which basically means Google is giving you time on one of their CPU with GPU. And we're going to run the code that they've already put out here in order to customize an existing image classification model. Now, the first thing, though, is we need to get images. So I went ahead and put photos of my shirts and my pants and stuff like that into the laundry folding robot, and had it take photos as it moved these things around. So they're in slightly different positions. You can see there's like a couple different photos of the same shirts showing up here, and they're all in slightly different positions. And that's so I can get a little variation and also just more images. You want at least a couple hundred images of each training set. And I only have 2 training sets here. There's the dad and the daughter. So you can see my daughter has various pants and shirts and stuff in this one over here. So you want to get a couple hundred sample images of your clothing, at least a couple hundred sample images of your clothing in here. And then you want to put them into a zip file. So the zip file that you see here, training.zip, is just a zipped up version of that. Now the first thing you do over here in MediaPipe Model Maker is you're going to upload one of those training.zip files. I've already done that. You can see them. They appear here. This is the file system that we're looking at on the left here. They appear on the left. And then we're going to just run the code that's on this page. So the first thing you do is you run the setup step. It installs Python. So to run this, you just click this button right here and it runs. It installs Python, pip, and MediaPipe Model Maker. And then we do this next one from Google Colab, import the files, et cetera, et cetera. So this is, click go on it and off it runs. In the next step here, actually the next step is importing the training data. And they assume that you're going to run this code down here. We are not going to hit go on that code block. Instead, we're going to make our own couple code blocks here. So all you have to do to run this is hit the plus code and then type in these words right here. I had to clear this out earlier. You can ignore that one. This unzip the training.zip into an image path content/training. So if you look over here on the left side, I've already run that step. And sure enough, under the content directory, we have this thing called training. And in there are a dad and a daughter folders. And here you can see all of the images that we uploaded there. So after those are unzipped, it's fairly easy. You're going to go down here and do the review of the data step. All that does is it shows what it sees in the content training directory, and that's the dad and the daughter folder. Those are the labels that we will use to label clothing either belonging to dad or to daughter. So it is important what you name those folders. Next step, you're going to go down here to create the data set. This just divides those images up into a training data set and a testing data set. And then down here, I actually changed these words right here. This used to be MobileNet v2. I changed it to EfficientNet Lite. And then I went ahead and ran the training. So I clicked go on this, and sure enough, it ran this retraining step, and it did all of these epics down here. We can actually rerun that, I guess. And while that's running, I'll show you the rest of this. After it finishes, you're going to click the model export. That takes all that training data where it retrained the EfficientNet Lite on your training photos. It's going to export that as a model, and then we're going to download it as model.tflite. And then the last thing down here, you're going to skip over these steps. You're going to go to import quantization, run the quantization config, and then run the export a quantized model. Then I downloaded that. I added these couple lines right here, files download, the int8, the quantized version of this, and the metadata. So what does that look like? What I actually end up with, if I jump back over here and look in my downloads directory, you can see that under today, I've got all of these different model names. So that's it. You're built up. You can set up your Raspberry Pi computer with commands in the GitHub and load up the code from that GitHub on your Raspberry Pi, and then take that custom image classification model that we just made, the TF-Lite int8 model, and put it on your Raspberry Pi and run it. And when you run the code, it's going to output what it's trying to do at every step, and it'll actually stop every so often and wait for you to hit enter. So you can inspect that everything's working the way you expect before you hit enter and continue. That should give you time to sort things out and figure out if there's any bugs in your setup. Now, looking to the future, this thing obviously needs to be made more resilient and ready to run outside on its own. The obvious things that I see, first off, the clothesline itself needs a little bit more tension, and the clothes pins need to be able to hold heavier clothes but still open when necessary. So a little bit of redesign there. We're going to need faster linear actuators, or better yet, just redesign that whole 3-axis linear actuator setup so that it's sturdier and faster, and it's always in line with the wooden folding bar. I'm thinking it all moves as one piece. Next, make the folding bars longer. I'm thinking 30 inches rather than 20 inches so you can fold larger things. Have more bins at the bottom of the slide and be able to put them on a chain so that you can move them back and forth. And that way you can sort multiple people and shirts and pants separately for each of those people. Next, I think enclose the whole thing and make it a smaller footprint. The biggest problem with making the footprint smaller is actually the camera has to be pretty far away from the clothes to get a picture of the entire piece of clothing. So maybe a fisheye lens on the camera so that it can be closer to the clothes and thus shrink the entire thing. And then last, I think improving the code to find the center of each piece of clothing. It gets confused with the background sometimes right now. And so maybe 2 cameras so that you can have like a 3D image of the clothing would make it much easier to figure out where it is and get it centered. Then the last obvious big change, we don't want to have this on a clothesline where it's already been oriented and hung for you correctly. You want it to be able to turn clothes right side out and orient them. But that's a really big, hard problem, and it's probably not going to be addressed in the next version of this. So maybe version 3 would attack that. Let me know what you think in the comments, and don't forget to like and subscribe for more unique and useful do-it-yourself builds.